PPT is visible to you all?
Yes, sir.
Okay. So this is our today's section. Today's class I will start with abrasive jet machining. Okay. Yesterday also we have talked about what is abrasive jet machining and how the material removal takes place, and we also discussed few process parameter about abrasive jet. And today we will first see what is the schematic diagram, means how this abrasive jet machining works. Okay. So here it is, as you can see in the screen, the schematic diagram of abrasive jet machining. So first in that, it will start from the left side. As you can see here, first there is a air compressor. What is the function of this air compressor? This air compressor will regulate or will operate the pressure needed. As you know, in abrasive jet machining, we use a high speed abrasive or high jet of abrasive for material removal. So for get that high velocity, we will use this air compressor. In that we can use normal air, we can use nitrogen, etc. We can use as carrier gas, which is known as carrier gas. Means carrier gas means that gas will carry your abrasive till your workpiece. So here in air compressor we will get our sufficient air pressure which will able to take our abrasive at the end point. So here one bulb is there to switch on or off, or you can regulate your air. Then there is pressure control valve, as you can see here, pressure control valve. So in that pressure control valve, we you can fix, you can regulate how much pressure you need. You can adjust using this air pressure. Using this pressure control valve, you can adjust the air pressure. Okay. And after that, there is a next section. It will comes dryer. So what is the function of dryer? As you, from the name you can say it will dry your air. There is a water contaminant and water vacuum are there, water particle are there. So in that dryer, those water particle that will keep dry, and we will get only the air compressor. The uh, dry air pressure you will get. And after that again another filter is there. This filter, if there is any ambiguity is there, if there is any what is we can say impurity is there, if any impurity is there in the air, that will get filtered, or other things which is not related, not needed for abrasive jet machining, those things will get filtered using this filter. After that, your air pressure or pressurized air, that will come in the mixing chamber. So as you can see here in the mixing chamber, there are two things. One one chamber is three things are there. One chamber is there. In the top there is abrasive feeder is there, and in the bottom you can find that electromagnetic shaker is there. So what is the function of this mixing chamber? In this mixing chamber, on the from the top you can see abrasive feeder is there. So through this abrasive feeder, we will feed our abrasive in the form of powder, in the form of grit. Okay. So accordingly, we will feed our abrasive the mixing chamber in this. And in the bottom there is electromagnetic shaker is there. So with the help of this shaker, we will shake this mixing chamber, we will vibrate mixing chamber, so that the abrasive particle can can easily mix with our carrier gas, uniformly mixed with our carrier gas. This is the function of electromagnetic shaker. So with the help of this abrasive feeder, abrasive will feed, and with the help of this electromagnetic shaker, we will shake this chamber and we will mix our abrasive with our carrier gas uniformly. Okay. After that, this carrier gas with till now till this up to this mixing chamber, there is only air pressure is there, only carrier gas will be there. But after this mixing chamber, here you will find the abrasive particle which is carried with using our carrier gas. Here you will find that carrier gas is carrying our small abrasive grid. Okay. So through this pipe, again you will find electromagnetic on off valve. So as per your requirement, you can make it on, make it off. If you don't need further abrasive jet, you can make it off, or when needed, you can make it on. So there is a electromagnetic on off valve there in this portion. Okay. So after that, those abrasive mixed with carrier gas, the abrasive mixed with carrier gas, that will come through this on off valve and it will come up to this nozzle. So as you can see, this nozzle is in taper size. So what is the function of this nozzle? There is two function. First is the nozzle, it will convert the pressure energy into energy. Pressure energy of carrier gas and abrasive, it will convert to your mechanical energy, and through this nozzle it will come. And also using this nozzle you can fix at which angle you will strike your abrasive mixed carrier gas with your workpiece, or you can of your using this nozzle. That's why uh, high velocity abrasive we can get. On top of that nozzle, there is a workpiece which is fixed in a fixture in a table. The fixture, or you can keep this workpiece. You can use different jig and fixture for, and the table, the table is, you can move X, Y, or Z direction. You can move your table in that way. So abrasive mixed carrier gas, it will at high velocity when it will strike in the workpiece, and due to different during different what we already do that, like here teeny brittle fracture. Okay, that high velocity or jet, abrasive jet, it will impact and cause a teeny brittle fracture workpiece. Okay. And a small piece will dislodge like this way. Fracture of work surface in this way, the work piece, a small part of work piece is dislodged from the work surface, and when as you know that the carrier gas pressure is there, jet is there. So during that pressure, that
Hello,
dislodged
sir.
particle will get removed from work surface. Yes.
Hello, sir. Sir, your voice is breaking, sir.
Now
No, sir. अभी भी break हो रहा है, sir.
due
Okay, sir. Some words are missing, sir. No, sir. अभी भी break हो रहा है, sir. अभी तो आप बोल रहे हो, अभी भी break हो रहा है, sir.
maybe network issue, but so as I already told that that nozzle it will decide at which angle you will strike on your workpiece and how much jet it will you will fall on the workpiece. So the distance, this distance, the nozzle and the workpiece, this between this distance, this is known as standoff distance. Thus, distance is very much important for workpiece removal. How it will affect on your material removal, that we will see in our next slides. So, and this table is movable. So, if you need a lengthy workpiece in the machining, that you can do by moving your work table. Okay. So, this is in a short way, you can say this is the schematic and working culture or working principle of your abrasive jet machining. Okay. So, in exam, it's come that discuss or explain the working principle of abrasive jet machining or working process of abrasive jet machining. In that case, you just need to draw this type of schematic diagram and you need to explain different steps. First, the air compressor thing, then there is a pressure control valve, then there is a dryer, filter, abrasive feeder is there, then abrasive mixed carrier gas, it will come through this on-off valve and using this nozzle, it will strike on your workpiece and that carrier gas, it will remove the small particle which will get removed due to the brittle fracture and when this process is continue for long time, then in the short period of time you will get material removal. So here we will share some videos so that it will be easy for you to understand, for your more better understanding. Let me play one video. Video means that you can say 3D animation type. Okay. So that you people able to understand it more clearly. Okay. So video is visible to you all. Video is visible to
No,
you
sir.
all. Okay.
No, sir.
So such type of video is easily available in the YouTube. So after the class, you can have an idea. You can play on YouTube and you can have better idea. Okay. So like this. This is a schematic. Okay. So this is the gas supply. Like in the power point, you have shown the air compressor. Through that air compressor, you will supply the gas. That gas may be dry air, maybe nitrogen, maybe carbon dioxide. So these dry air, nitrogen, carbon dioxide. These are known as carrier gas. Okay, so that carrier gas it will go through filter and dryer, and after that there is a pressure gauge is there. In that pressure gauge, you can fix, you can regulate, you can adjust your pressure, and then that pressure will come in a mixing chamber. Okay, and in mixing chamber is connected with a vibrator. Vibrator is in the PPT have seen electromagnetic shaker which will vibrate your mixing chamber. And after that, there is a control valve is there which will control this all the mixing pressure. After the mixing chamber, there is powder supply. You get powder supply or abrasive bead supply. You can say okay, and all are connected. And here you will using this control valve, you can adjust the abrasive air jet. Okay, and then it will come to the nozzle. So nozzle here also you can see in the taper section, which will direct your abrasive jet as well as it will make pressure energy into kinetic energy. Okay, so you can see when the air pressure is also given and power supply is given due to the vibration, the vibrator vibration will generate and it will easily uniformly mix. The carrier gas will mix with powder supply or abrasive bead and then it will follow this path and follow this through this control valve it will come to the nozzle and after that nozzle using this nozzle you can do the machining means your workpiece will be fixed using fixture on a machine table. So in this way, you can do the machining or material removal using abrasive jet machining. So material removal here will take place. Okay, material removal will take place in the form of, like here we told that due to the brittle fracture, teeny brittle fracture would generate and which will dislodge some small workpiece particle. Okay, and then the water carrier gas jet that will take away those dislodged work, workpiece particle. So in this way, you can do the machining using abrasive jet machining. Okay. So now, what are the different process parameter for abrasive jet machining? Like first important thing is abrasive. So for abrasive, there aluminum oxide, silicon carbide, that the things we can use very hard material. We should use as an abrasive, and their shape, it may be irregular shape, it may be spherical shape, abrasive grid. So how to make this abrasive grid in a particular size, that we already discussed in our previous unit, which is powder metallurgy. That we have seen that how we can make different size, different shape powder. So in abrasive, you can the abrasive size may be 10 to 50 micron. Then mass flow rate. At how much mass flow rate means at how much feed you can keep the abrasive onto the mixing chamber. That is 2 to 20 gram per minute. Then, as I to know, as you all know that as a carrier gas, you can use air, carbon dioxide, nitrogen, or composition of that all those things. Okay. Then air density should be 1.3 kg per meter cube. Then air velocity 500 to 700 meter per second. Air pressure 2 to 10 bar. Air flow rate 5 to 30 ppm. Okay, so these are the different parameters which we should follow if we in respect of your carrier gas, whatever the carrier gas you can use. So all these parameters you need to follow. Then abrasive jet. Now it will come after this, up to this carrier gas means up to this line, or you can say up to before the mixing chamber. So after this mixing chamber, it will become abrasive mixed with carrier gas. Okay, so then we need to follow this abrasive jet. The jet velocity will be 100 to 300 meter per second depending on what material you are using, or how much material removal you need to take. Then mixing ratio means mass flow rate and the uh, mass flow rate and the of abrasive gas. Okay, mass flow rate of the abrasive divided by your carrier gas. So this is known as mixing ratio. So it should be followed. Then stand of distance. What is stand of distance? We can see in the next slide. We will see. So 0.5 to 5 mm your stand of distance. Correct the stand of distance. Then impingement angle. If you want in a machining to be done in an angle, you can vary it from 60 to 90 degrees. Then another important is nozzle. So again, nozzle should be also very much hard material because it is always come in contact with the abrasive jet. Okay, so if you use very soft material for making the nozzle, then it will break before the actual machining. So that's
सर
why, yes,
सर अभी वो गेस्ट लेक्चर है 11:15 को.
हाँ तो
वो करना है कि ये वाला लेक्चर करना है, वो ही बोल रहा है.
गेस्ट लेक्चर किसका है?
सर वो BS6 टेक्नोलॉजी.
Again, as the nozzle is very much important part of important part part for abrasive jet machining, that's why you should follow these parameters for nozzle. Okay, so material it should be very much harder than diameter. Internal diameter should be 0.2 to 0.8 mm. Then if life means how much long it will work. So you can say 10 to 300 hours can work. So after that, you can see here where in this diagram you can see different parameters effect on MRR is shown. So this is very much important slide. So first you can see that abrasive flow rate effect on MRR. In this first diagram, we have shown the abrasive flow rate effect on MRR. So you can see if DC means grid diameter, abrasive grid diameter. Okay, so if you increase abrasive flow rate and also you can increase the grid diameter, then you will find that MRR initially it increases exponentially. It is increases, and after certain period of time it again get decreases. MRR getting decreases. Okay. So if you increase your grid size, then also the same formation, same type of formation in the graph you can find. So if you increase abrasive flow rate with varying grid diameter, the MRR will get increases with the increase in grid diameter, and after certain period of time it again get reduces. Okay. So what is the reason for that? That if you increase the abrasive flow rate, okay, then means your jet velocity get increases. Abrasive jet velocity get increases. Also, you are increasing the grid diameter. So, so what happened when this abrasive high velocity abrasive flow it impinge on this workpiece, then gradually MRR more material will get removed because you are increasing the abrasive jet velocity. Okay, but after certain period of time, what will happen? There will be the dislodged work material. Okay, those material which is get removed on the due to the action of abrasive jet, there is a saturate on this work surface. Okay, so uh, as it gets saturated on the work surface, so there will not be that much pressure that which can withdraw all the dislodged work material. So they will make a secondary surface on the work surface. So when you more increase your abrasive flow rate, there will be less chance of MRR. Means MRR will get reduces because those abrasive, those dislodged particle, it get impinged on the work surface and it will restrict the more material removal. That's why we will see that first the increasing of abrasive flow rate, MRR first increases and after that, after some time it will get gradually decreases. Okay. So this is the effect of your abrasive flow rate with MRR. Next, next we will see the effect of mixing ratio. Mixing the next material part process parameter is mixing ratio. Mixing ratio means at how much ratio we are mixing one abrasive particle divided by your carrier gas. So how that ratio. Okay. So here also you can see that same type of phenomena you may find. If we increase the mixing ratio, you will see that the MRR will get increases exponentially. Here, how much rate it is increasing, here MRR increasing rate is much more higher than the previous graph. Okay, so if you increase the mixing ratio, it will the beginning it will increase exponentially, and after some time, after some point, it will again get gradually decreases. So this phenomena can be again described in the same way. If you increase the mixing ratio, the air velocity will also get increases, carrier gas velocity will increases, as well as abrasive more particle will come in the abrasive jet. So in the beginning, more material removal will take place. But after some time, what will happen? Those removed particle will not able to remove fully from the work surface. So in that cases, those removed particle which will not will be able to remove from the work surface, they get stuck on the work surface. So that will again restrict your MRR. Okay. So then MRR will get increases. So now in the third graph, we can see the abrasive flow rate effect on MRR. So if you increase the abrasive flow rate and your mixing ratio you are making constant, you just increasing the abrasive flow rate. So in that cases, MRR will gradually increases. See here the graph, MRR gradually increases. Okay. So that is the effect of abrasive flow rate on MRR. Now in the fourth graph, you can find that gas pressure effect on MRR. If you increase the gas pressure for constant mixing ratio and also if you are increasing gas flow rate, then you will find that MRR is increasing. Okay, and after certain period of time, it comes, it will get reduces. The MRR get reduces. Okay. So in this slide, you can see different effect of different process parameter on MRR during AJM, abrasive jet machining. Okay, so this is an important topic or important slide where we can find that different effect of different process parameters on MRR during AJM. So now here you can see we are talking about in abrasive jet machine the standard distance. Okay, so this is standard distance and its effect on material removal. So here if you can see there is these are the some experimental data. By some experimental data they have come out with this conclusion. Okay. So if you see, if your standard distance is 0.75 mm, then your width of the workpiece will be near about 0.5 mm. Okay. So again in the next, if you more increase the standard distance, suppose up to 1 mm, then you will find that the width get increases. Okay. And that width is here, if you find, if you can see this direct straight line, direct material removal takes place. Okay, but here in a diameter, in an angle, you will find it is 90-degree angle. The machining will be done, and the width is 0.5 mm. But here, if you increase the standard distance, you can see the width get increases as well as it is not straight. It is not like that. The machining is not in the straight way. It get diverted, little diverted here and here. So more tapered type, you can say tapered formation, more cavity is formed in that way. So if you increase that standard distance more, suppose 1.5 mm, then the width also get increases and that inclination it also get increases here. More inclination you will find. Again, if you increase the standard distance up to 2 mm, then more inclination and the width becomes 1.5 mm. And if you If your standoff distance is less, then you will get that more depth penetrate material removal takes place. But as you increase the standoff distance, if you increase the standoff distance, then you will find that that depth will get reduces, but the width get increases. So these are the effect of your standoff distance with your material removal in abrasive jet machine. Okay. So these are the ratio at which the abrasive jet machining affect the standoff distance during abrasive jet machining effect in your MRI. Okay, so in this we have seen what is the abrasive jet machining and how the material removal takes place. Okay, then what is the working things, working process, or the schematic diagram? We have understood that. Then we have seen different types of process parameter which is important in abrasive jet machining which we must follow. Then we have seen different process parameter effect on MRR during abrasive jet machining. Then also we have seen what is the effect of standard distance at material removal rate or material removal, or you can say the design of material removal with very standard distance. So after that we will continue with a new another advanced machining process which is known as ultrasonic machining USM. Okay. So in ultrasonic machining we use mainly brittle work material. Okay. In ultrasonic machining it is based for brittle work material. So material removal primarily occurs due to the indentation of the hard abrasive bleeds on the brittle work material. In USM, how the material removal takes place? Material removal takes place due to the indentation of hard abrasive bleed. So here also we use different hard abrasive bleeds on brittle work material, and due to the constant vibration. Okay. The constant vibration means that those vibration will make good indentation using hard abrasive bleed and material will get removed. Okay. So other than this brittle failure of the work material due to indentation of some material removal may occur due to free flowing impact of the abrasive against the work material and related solid-solid impact erosion. So first one is due to the brittle fracture. So for two reasons material will get removed. First one is due to the brittle fracture or brittle failure. Next one is due to the indentation of the work material. Due to the indentation of the free flowing impact of abrasive bleed, work material get removed from the workpiece. Okay. Then how we'll give the indentation using a transducer, using a tool, we give the indentation, and that indentation will impact on workpiece with the help of abrasive bleed. Okay. So during indentation, cracks will develop just below the contact side, just below the tools and abrasive bleed. In that, cracks will form. Then as indentation progresses, the cracks would propagate due to increase in stress and ultimately lead to brittle fracture of the work material under each individual interaction side between the abrasive bleed and the workpiece. So here it may not be clearly visible to you or clearly understandable to you, but later on with a 3D animation you will understood that how this ultrasonic machining occur or work. Okay. So during when you provide vibration on the tool, and below that tool there will be abrasive grid, and that due to the constant indentation there will be stress will generate. Okay, and due to that artesian contact stresses, cracks will develop, and when the more machining will be done, then those cracks will propagate and it will increase the stress. And when the stress will increase and cracks will propagate, that will lead your brittle failure of the work material. Okay, and in that way, the workpiece get removed from work surface. So here you can see that we are providing vibration on the tool. So the tool material should be hard enough that the indentation by the abrasive grid does not lead brittle failure on your tool material. So that we should uh, understand that, or we should keep in mind that the tool material, when we select the tool material, it should be hard enough, it should be strong enough, the indentation of the abrasive grade does not lead brittle failure of your tool. Okay. That's why your tool should be tough, strong, and mainly using ductile material. So, like different stainless steel, different other steel, different other metallic alloys, you can use produce different tools in ultrasonic machining. So, basic ultrasonic machining process involves a tool which is made of ductile or tough material vibrating with a low amplitude and very high frequency, and a continuous flow of an abrasive slurry in the small gap between the tool and the workpiece. So, in this way, the basic USM process continues. So, again, I am repeating, the USM process involves a tool. There would be a tough ductile material tool would be there, which will vibrate with a low amplitude and high frequency. And below that, we will continuously flow the abrasive slurry. So during the process, the combination of abrasive slurry and combination of this vibration, the indentation will take place. And during the indentation through the abrasive grid, the material will slowly remove from the workpiece material. So the tool is gradually fed with a uniform force. So always the tool is as a uniform force you will providing. Okay. The impact of the hard abrasive grains fracture the hard and brittle work surface, resulting in the removal of the work material in the form of small wear particles. Okay. The tool material being tough and ductile wears out at much lower rate. So as your tool material is much harder by some tough material, some ductile metallic alloys, so the wear out will take less on tool material. So now, what are the reasons that material get removed during ultrasonic machining process? First is the hammering of the abrasive particles on the work surface by the tool. Continuously, you are hammering on the work surface by using different tools. Then the next reason is the impact of free abrasive particles on the work surface. Free abrasive flow of the abrasive. Okay. Then the erosion due to cavitation. So when due to the crack formation, then cavity will form, and then from that cavity again erosion will take place. Then chemical action associated with the fluid use. So as we already told that we are using abrasive slurry. Abrasive slurry means some fluid is used with abrasive. So during the chemical action also the material get removed. So a formula is given for material removal rate, which is you can say that associated with volume of your work material removal per impact and number of particles making impact per cycle, then frequency. So if you increase the volume of work material removal impact, then it will material removal rate will increase, as well as if the number of particles making impact per cycle, if you increase that, then also your material removal rate will increase, as well as if you increase the frequency, material removal rate will increase. Okay, so this is schematic diagram of working principle of USM. So here you can see the horn. Horn means you can say in the tool we can give using the tool is fixed through a horn. So that force is directly given to horn, and through the horn it will come on the your tool. So vibration is given on the horn. Okay, the vibration frequency 19 to 25 kilohertz. Then one amplitude is given, as I told, that small amplitude, which is up to 10 to 15 micron. Okay. Then continuously you will provide abrasive slurry. So this will vibrate like this. This will vibrate, and due to the vibration indentation through this abrasive bead, it will impact on your workpiece, and gradually material will get removed on the work surface. So this is your USM machine, you can say. Okay. So here from the beginning, there is a feed is to regulate the feed motion. The system is there. Then transducer is there. Transducer produce this vibration. Okay. Then horn, with the horn, the tool is connected, and through this horn, vibration will take place on this tool, and we with this arrangement we will provide the abrasive slurry. And during the continuous vibration amplitude, the material will get removed from this workpiece. Then the slurry, which are not extra, or you can say extra slurry, that we can take out using this return slurry pump. Okay, and it will store in the slurry tank. After that, after this process, you can again use those by some filtering. You can again use this slurry. So this is your setup of ultrasonic machining and the working principle. Okay. So now in a video with see in a 3D animation video, you will be able to understand how it works. Okay. So here we will see working of USM. So you can see here an abrasive slurry is given on the workpiece, and this tool which is continuously vibrating. You can see how it is vibrating, and below that we are continuously providing the abrasive slurry in a 20 to 30 kilohertz frequency. Vibration of the tool and abrasive slurry removes material in the form of small grains. In the machining surface, this way after machining. So this is the different elements in ultrasonic machining. So this is a 3D model of your USM ultrasonic machining. First one, there is a important part is velocity transformer, which is specially designed for tapered section connected between transducer and the tool. Okay. So this is your transducer, and this is your tool. And through this power supply, so in that power source there are electronic oscillator amplifier is there to regulate the energy, or to regulate the transducer. So through this transducer, it converts electrical energy into the mechanical vibration. Okay. So after that, through this transducer, you are giving vibrating motion on your cutting tool. So suppose power is given. Okay. So people able to understood what is the how this abrasive USM works. Student. So next is how this different horn, okay, or you can say concentrator. Also you can say here. So the main units of an ultrasonic machining unit as shown in the figure below. It consists of the following machine components. So here, machine components you have seen here. So the acoustic head, the feeding unit, the tool, the abrasive slurry, the pump unit, the body of the work table. Yeah, the body with the work table. So these are the main units in ultrasonic machining, which you already seen in your in the video. Then depending on that, what type of machining you want, or means what is with the after machining, what will be the workpiece surface design. Depending on that, we can use different types of horn. So it may be in conical shape, it is known as conical horn. There is tapped, there is exponential. So these are the different horn you can use. Here, this horn, or it's also concentrator. We are talking about this part. Okay, these are the three different types of concentrator if shown here. Now, different process variables which are very much important in ultrasonic machining. First, amplitude of vibration, it is 15 to 50 micron. Then frequency of vibration 19 to 25 kilohertz. Then feed force, it is depend on tool dimension. Then feed pressure, it is another important. The abrasive grid size, in micron to 150 micron. Then different types of hard abrasive particle that are made of different material like SiC, boron carbide, silicon carbide, diamond, aluminum oxide, like this. Okay. Then flow strength of work material, that we need to know. Then flow strength of the tool material. Then contact area of the tool. So contact area of the tool that can decide by using different types of horn like conical, step, or exponential. Then volume concentration of abrasive in water slurry. So how much volume of abrasive are there in a water slurry? That is very important process parameter during ultrasonic machining. Okay. So what are the important process parameters that can affect your MRR? There are frequency, then amplitude, the static load, feed force, okay, hardness ratio of the tool and the workpiece, then your abrasive grain size, then concentration of the abrasive in the slurry. So these are the important parameters which affect the material removal. Okay, the abrasive slurry, the most common abrasive are, as we already discussed, all those things. Okay, and to make the abrasive slurry, generally we use water. Okay, and after along with water, we can use benzene, glycerol, and oils also we can use to make the abrasive slurry. So in a summary, you can from this slide, all this abrasive ultrasonic machining, USM machining, what is the different parameters, how it works, all this in a short you can find here. Okay, so today we maybe go little fast. because there is less time is there. Your CA3 is coming, so that's why we maybe go little fast in ultrasonic machining. Okay, so in this way we can remove material by using different non-conventional energy source. Like in the previous AJM, we have seen that we are using abrasive grid to remove the material. Here also we use abrasive grid, but with that we introduce the frequency, ultrasonic frequency, to remove our work material. Okay. So today up to this, and tomorrow we will again continue with different other advanced machining processes.
So study material, sir.